Hi guys, today I'll be talking about the Born interpretation, which is under chapter 6 in the modern physics textbook, section 1. So the modern interpretation deals with the wave function psi, which contains within it all the information that can be known about a particle. So from this, we get to know that the probability of finding an object at a position x is gotten from the absolute square of psi. And this is because psi on its own is a complex number, so psi on its own cannot be measured. But when psi is squared, we can then find a real non-negative number which can be measurable. This brings us to the Born interpretation of psi, which says that the probability that a particle will be found in the infinitesimal interval dx about the point x is denoted by this p of x dx equals to psi absolute square of psi dx. So let me give you an example of two different waveforms we have over here. From this waveform, we can see that this waveform is easy to look at, it's smooth, and from this we should be able to say that we can measure this. But from this waveform, we can see that it's scattered, it's very difficult to measure this. So one thing that we get from psi is that psi should be a single valued and continuous function of x and t, so that no ambiguity can arise concerning the predictions of the theory. So that means that instead of us having a psi like this, it's always better to have a psi like this, because this is very easy to measure compared to this, because for this it will be hard for us to find the probability of this over here, this waveform here, compared to this waveform here. Also, because the particles must be somewhere along the x-axis, the probability summed over all values of x must add to 1. So this means that since the probability of finding the value x here is going to be summed to 1, because we're just, so this is the so basically, to find the probability of this waveform, we know that x is going to be somewhere within this waveform. So we know that because of that, it's going to be equals to 1. And this gives us this equation that the integral of p of x dx is equals to the absolute square of the integral psi dx, which will be equals to 1. Lastly, we should know that when we're given a finite, we should know that when we're given a finite interval like this equation here, the integral from a to b of this absolute value of absolute square of psi x of t of dx, then we know that the probability is just the area included under the curve of probability density between the points of x equals to a and x equals to b.